Okay, so here's the Wireshark capture. I've filtered for OSPF. We've got our two routers once again. This is router 1, this is router 2. This is not an easy one to work out. Let me start with router 2. So if we look at router 2, we can see hello packet, we can see router ID, we can see, and I'll just move this up, we can see password. There's the password. In the OSPF packet, we can see the subnet mask. We don't see designated router, backup designated router in the output. We see data block, not too much here. Extended TLVs, don't see too much. That's interesting. Let's see if we can see a difference on router 1. So router 1, backbone area, and this is what's nice. You can jump from one router to the other. So this is router 1, this is router 2. That looks right. Simple password, router 1, router 2, that looks the same. Authentication, same password. Subnet mask, looks the same. Hello interval, okay, here's something different. Notice hello interval's 10 seconds. Hello interval here is 30 seconds. If we look at dead interval being 120 seconds, the other router is 40 seconds. Now this is something in OSPF as well that you need to be careful of. If the hello interval is different, they're not going to form a neighbor relationship. Dead interval is different, they're not going to form a neighbor relationship. If the two routers don't form a neighbor relationship, they won't exchange routes with one another and routing will be broken. If we have a look through the output here, we don't see any exchange of messages. We only see hello packets. They will never form a neighbor relationship because the intervals are different. So what I'll do is run the Wireshark capture again so you can see this in real time while I'm fixing it. So what we'll search for is OSPF. We see both the routers advertising, and if we look in the packet, notice we see a difference between hello interval on the one router and the other router. So router 1 has a 30-second hello interval. Router 2 has a 10-second hello interval. That's not right. Either the OSPF network type has been changed or hello timers have been changed on the routers. They are not the same. This is Ethernet. They should be the same. So something's been changed either on the OSPF network type or on the hello and dead intervals. That's typically done on an interface. So show run interface gigabit 01. Notice this option here is the problem right away. I know this because I've been working with OSPF for a long time. You may not be aware of that, but be careful. In OSPF, the network type has to be the same. Another way to look at that is to type show IP OSPF interface. And let me do a specific interface, so gigabit 00. So show IP OSPF interface gigabit 00. That's this interface. On the router on the right, show IP OSPF interface gigabit 01. That's this interface. Notice what we see here. We don't see that on this side. We see priority. We see DR. On this side, we don't see DR. That was another giveaway. So if you go back to the Wireshark capture, notice on the one router, router 1, designated router and backup designated router are set to 0000, whereas on the other router we have a designated router. Now there's no backup designated router because router 2 sees itself as the designated router, but router 1 is not using a broadcast medium. It's set to point to multi-point. So it doesn't go through an election process. It doesn't take part in the election, so there's no backup designated router. Router 2 sees itself as the designated router, no backup designated router, but router 1 doesn't see either. That is a giveaway straight away, apart from the timers. That tells you that there's a problem between these two routers. Now, they don't have to both use broadcast. They could use point to multi-point, but on Ethernet, you want to use broadcast. That's the default mechanism used. You can see the network type right over there, broadcast. You can see over here network type point to multi-point. They need to be the same, otherwise they're not going to form a neighbor relationship. So show run interface gigabit 01. What I would do here is type IP OSPF network. Notice the options. I'm going to select broadcast. So show run interface gigabit 01 again. Notice network is broadcast over there. You see the black in Wireshark. Neighbor relationship has been formed and the routers are starting to advertise routes to one another. So we know this is working just through the Wireshark captures, but you can also see that on the consoles of the routers. Notice neighbor relationships are formed. So show IP OSPF neighbor. Neighbor relationship is established between those two routers. Notice full BDR. In other words, router 1 is the backup designated router. On this side, show IP OSPF neighbor. Router 2 is the designated router. This is looking at it from router 1's point of view. Show IP route. Routes have been advertised. They are shown in the routing table. So on the two PCs, they can now ping one another. We've successfully resolved this network issue. The hint or the thing to look out for was, notice designated router, backup designated router was zeros, and the timers were different. So if we scroll down to when the change was made, notice we see the timers as 10 second on the one and 10 second on the other. It doesn't show us the designated backup designated router yet because it's still going through that election. But after a while, we should see that. Notice DR, BDR. Once they successfully elected and told each other about one another, and then they exchange routes with each other. Okay, so I'll save this Wireshark capture. I'll stop it here, and then I'll save it as OSPF TS3 fixed. So if you want to see what it actually looks like once it's working, there you go. Okay, so how are you doing with these troubleshooting videos and labs? It's not that easy, but it's a real test of your networking knowledge and whether you can analyze packets properly.